Look at two sections today, 7.5 and 7.6. They're the three basic, they're the same basic trig functions. There's three of them. The first is called the tangent ratio. So if you have a right triangle, so we have a right triangle here, and I'll even give this some names. So what we call this like triangle A, B, C. The tangent ratio is the following. It's the ratio. It's the tangent of an angle this tangent ratio, or the tangent of an angle, is equal to the ratio of the opposite side to the adjacent leg of a triangle. The tangent of an angle. So if we're in a triangle, we want to find the tangent ratio of an angle. We'll pick one of the angles. So let's say we find the tangent ratio of angle A, or tangent of angle A. The tangent of angle A is equal to the ratio, or the fraction, of the length of the opposite side compared to the adjacent leg. We're calling legs are the sides that make up the right angle, and the hypotenuse is what's across. So how would we call these? We give these some names. So in a triangle, we generally label angles with capital letters, and then the opposite sides we label with like the same lowercase letter. So like if this is angle A, then we generally call the opposite side of angle A like lowercase a. If this angle is capital B, we'll call the opposite side lowercase b. If this angle is C, we'll call the opposite side lowercase c. So what should the tangent of angle A be? What would be the ratio there? What would be the length? Andrew, you're like itching to try.
A to B, what's it? B.
Is it B?
Yes.
It is. The tangent of A is equal to the ratio, or we'll divide the opposite side to the adjacent leg. Where's the adjacent leg? The leg that touches the angle. In this case, the only leg is happens to be B. So whatever the length of A is divided by the length of B is what we're going to call the tangent of this angle A. Whatever this angle is, its tangent is A divided by B. This is true. This is only true in right triangles. We'll call this. Okay. How about what would the tangent of angle B be? What would the tangent of angle B be? Opposite side over adjacent leg. Which is the adjacent leg? Sure. C cannot be a leg because C is the hypotenuse of a right triangle. Right? So C will never be a leg in this case. Okay, so if we're going up adjacent leg, it's never going to be, we'll never choose the hypotenuse as what we're dividing by, as far as the tangent goes. So we actually put this to use. So let's find the tangent of angle A and the tangent of angle B in each of these. So what would be, say, tan of angle A in our first example? 21 over 20. Opposite side over adjacent leg. What's the tangent of angle B? Sure. That'd be the two tangents. Yeah, that's it. Find tangents. Find tangent A and tangent B in example B. Tangent of A would be what, 48 over 14, which is equal to what, 24/7? What's tangent B?
14 over 48.
Is 14 over 48, which reduces conveniently to what?
7 over 24.
7 over 24. Okay. One of the more important reasons, so this is kind of cute to find if you don't have angles, you can just find tangents of angles. That's great. It's more useful if I actually tell you what the angle is and we want to find like a missing side. So like in example 2 here, this time I don't tell you what one of the two sides are, but you do know the angle measure. One of the reasons why this ratio and the other two we're going to see in just a second here are so important is that if we have a right triangle, no matter what the side lengths actually are, these ratios are always the same for any given angle. So if you knew what the angle measure is, you know that the ratio of these two sides is always going to be whatever value we come up with. So we can use that actually if we know one of the sides to find the other. For example, in this case, I know that if I'm looking at this angle, I know that its tangent, the tangent of 55 degrees, is equal to what value, what fraction, what ratio? Well, what's tangent defined to be?
X over
Opposite side over adjacent leg has got to be equal to x over 30. Or, maybe another way to write that is, how about we solve for x? We can multiply both sides by, say, 30 by the denominator, and get 30 times the tangent of 55 degrees is equal to x. And we can actually get a value with this if you have any scientific calculator. Graphic calculators are even nicer. Okay. You can do the following. This is just some ratio that we can type in the calculator and get a number for. And you can say x is equal to 25 divided by the tangent of 45, whatever that happens to be. And what's the value of x? Anyone come up with it? If you're in degree mode, you should get x is 25. So?
But if it's like a 45, 90 degree angle, do you even have to do that?
You just noticed one of the nice trigonometries. So the tangent of 45 is always 1 because you get it from a 45, 45, 90 triangle. So yeah, you didn't have to. You could have done this with special right triangles.
I just didn't know if it was just like generic. Just like
No, I just wanted to show you how to do it with a tangent. Or you could do it with knowing the special right triangles. Sure. But the tangent of 45 is always has to be 1. How about C? I think you could try C and D on your own. I feel like something that we can accomplish. Let's try C and D on our own. Hopefully you set up tangent of 34 is equal to x over 15. Multiply both sides by 15, you get x is 15 times the tangent of 34. And in degree mode, what is this about approximately?
1022. Oh, you were typing this.
So we should get x is approximately 10.11. Similarly, if we're using here, you could go tangent of 40 degrees is equal to opposite over adjacent. Then you'd have to say multiply both sides by x and divide both sides by 40, and you'd get this expression. You'd get what? X equals 30 over tangent of 40. Yeah.
Why can't you times 30?
So I gotta get x by itself, right? So if I divided both sides by 30, because that would get 30 out of the numerator, then I'd have tangent 40 over 30 is equal to 1 over x. But I don't care what 1 over x is, I want to know what x is. So one way would be, you could if you wanted, you could say this is over 1 and cross multiply and solve it. It's basically what we're doing. Okay. And you get a value. What's the value of this?
35.7.
Those of you that have a calculator, try this. Let's see what we get if you do the following calculation. What's the value of this thing? 30 times the tangent of 50. Can someone find 30 times the tangent of 50 degrees?
35.7.
Oh boy, that was almost that's like the same answer. How did I come up with that? Anyone know how I came up with that?
Oh, it's because X is on the bottom. Or X is on the top. I don't know.
Tangent is opposite over adjacent. What's this angle measure?
Oh,
50?
50.
So if you don't like multiplying by x and dividing by tangent, there's nothing that says you couldn't say calculate what this angle is, since you have enough information. And say tangent of 50 is x over 30. Instead, tan 50 and this triangle equals x over 30. And you just multiply both sides by 30 in one step. Gets you, as you just proved to me, the same thing. Gets you the same darn thing. Kind of nice. Okay, we're going to actually throw in the other two basic trig functions today as well, which are called sine and cosine. Two more, sine and cosine. Sine ratio is sine is equal to opposite leg over the hypotenuse. It's called the sine ratio, not the sin ratio. It's abbreviated with 3 letters, S-I-N. It's the sine ratio, not sin. Do not pronounce it sin. That annoys me. It's sine. Sine ratio. Sine of an angle is equal to opposite leg over hypotenuse. The cosine ratio, not the cos ratio, it's cosine. Cosine of an angle is equal to the adjacent leg over the length of the hypotenuse. Okay. So let's see. We'll go sine. How about we'll go tangent of r? We said is the angle r is 8 over 6. What's the sine of angle r? Opposite leg over hypotenuse. So angle r, what's the opposite leg? 8. And the hypotenuse is 10. What would be the cosine? 6 over 10. Cosine is adjacent leg over hypotenuse. adjacent line over hypotenuse. And you can play the same game with angle S. Tangent. What's the tangent of S? Tangent, opposite over adjacent?
6 over 8.
Opposite over 8. How about the sine of S? Opposite over hypotenuse. And what's the cosine of angle S?
8.
One more time. You may notice some relationships in there. Say like the tangent of opposite acute angles in a right triangle is just the reciprocal. They're reciprocals of each other. And sine and cosine, if you flip the adjacent angles, if you flip the acute angles, then you flip the values of sine and cosine. You notice it? Before you try, you can do it on your own if you want right now. But let's kind of skip ahead just a touch. Let's get better. What if you're like this person? What if you're finding yourself thinking something to the effect of, how the heck does Mr. Fisher expect me to be able to keep these things straight? He's crazy. Have I got something for you? You've got pretty much, this is more or less math, definitely trigs, but math, one of math's most famous acronyms, maybe even more famous than PEMDAS, is the acronym SOHCAHTOA. SOHCAHTOA. Generally, it's written straight across. I wrote them going down to help you, give you space to write in what all these various things mean. It's the kind of the stupid way to memorize or to help keep straight of what all the different ratios are. So, meaning sine is what? Opposite over hypotenuse. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And what do you think TOA is going to represent? Okay. And what is tangent made up of? Opposite over adjacent. SOHCAHTOA. Generally written just in a row. Probably one of our most famous acronyms. It helps you remember what sine, cosine, and tangent are. So if you're going through, it's not a bad idea to kind of memorize this, however you want to do it. But it's just a tool to help you kind of keep these three things straight. So if we're in a right triangle, you can use this idea of SOHCAHTOA to maybe help you remember and figure out what these sines and cosines are. What say the sine and cosine of angles R and SR? Up here, sine, cosine, tangent. Okay. If you already haven't, quickly run through and jot down what the sine and cosine and tangent are for angles R and angles S in this previous example. Okay. And then the last part for today is to use those ideas. To use now sine and cosine to find two. I got just two examples, and we'll be done. Okay. So if I give you, say this triangle here, and I only tell you the hypotenuse, I want you to find each of these two sides. Well, what are some things we could do?
Couldn't you figure out what
We could use that idea of SOHCAHTOA. Or how about let's set up a sine, cosine, or tangent ratio to help us find either A or B. Ideally, you'll pick a ratio so that you know the angle and you know one of the two sides. And you're going to find the third. So for example, I'm going to need to pick a ratio that uses this angle 50 and this side 10 and only one of these two missing pieces. It doesn't really matter which one, just give me something. Angle 50. How about We could say b. How about b over 10? Sure. And what's b over 10?
No.
Tangent is opposite over adjacent. Sine is opposite over hypotenuse. So if we did sine of 50, we'd get opposite over hypotenuse. Or we get b over 10. Okay, so what's another way we could find, what's the way we could find angle A then? Or sorry, not angle A, side A. Well, we have A. What is A in relation to this 50? What type of thing is it? Is it an adjacent leg, an opposite leg, a hypotenuse? It's an adjacent leg. So we have 50, we have an adjacent leg. What's one of those trig functions that uses adjacent leg? Tan uses adjacent, opposite over adjacent. So we'd have b over a equals 50 equals tangent of 50. How about a different one? Cosine uses adjacent over hypotenuse. So we can say cosine of 50 is equal to a over 10. And these functions work identical to the tangent thing. So if you want to solve for a, we can multiply both sides by 10. And get a is equal to 10 times the cosine of 50. Cosine is like the one right next door to tangent in your calculator. Again, be sure you're in degree mode, not radian mode. You want to be in degree mode. Here you come with a value for a. You can do the same thing and come with a value for b. Multiply both sides by 10. 10 sines of 50 is equal to b. Each of those buttons are located on your graphic calculator right next door to the other.